Hello everyone. On this video we will be looking at graphs of trig functions. Okay, but first we're going to do a quick review over our unit circle. Okay, so if you remember that cosine of theta is equal to x over the radius, but since our radius is 1 on a unit circle, it's just equal to x. And sine of theta, or your angle theta, is equal to y over the radius. Right, like I said, on a unit circle, your radius is 1, so your sine is equal to y. That means on your unit circle, since it's your xy coordinates, it's cosine of your angle and your sine of your angle. So if you're looking for cosine of 30 degrees or cosine of pi over 6, that would be square root of 3 over 2. If you're looking for sine of 3 pi over 4, this is your 3 pi over 4, and since sine is your y, it's square root of 2 over 2. If you're looking for cosine of 3 pi over 4, cosine is your x, so cosine of 3 pi over 4 is negative square root of 2 over 2. Okay, so what we're going to do here, we're going to get all of these values of pi over 6, pi over 4, pi over 3, or 30 degrees, 45 degrees, 60 degrees, and we're going to create graphs along the xy axis that's not a unit circle. All right, so this next page, you don't have to worry about memorizing these or anything like that. This is just showing you the value. Okay, so we know that sine of 30 degrees, or pi over 6, is 1/2, which is 0.5. And pi over 4, or 45 degrees, sine of that is square root of 2 over 2, which is 0.70711, and it keeps on going. And sine of pi over 3, or 60 degrees, is square root of 3 over 2. Plug that in your calculator and you get 0.86603 and blah, 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 and it keeps on going. And sine of pi over 2, or sine of 90 degrees, is equal to 1. Same thing with cosine of 0, cosine of square root of 3 over 2, cosine of square root of 2 over 2, cosine of square root of, well, basically 1/2, and 0. Okay, and I have this all the way down to 2 pi. And again, you don't have to write this down or memorize it. I was just showing you that each of those values, those square root of 2 over 2s, the square root of 3 over 2s, all of those have decimal approximations. And that's what we're going to use to graph. Okay, so we're going to go ahead and move on to our first graph. Okay, so we're going to look at our sine. Okay, so we're just going to write out here sine. Instead of sine of theta, I'm just going to make it sine of x. Okay, so we have our y between 1 and -1. Okay, so if you look back again, just for a quick second, sine of 0 is equal to 0. So it starts right here. Okay, so sine of pi over 6, or 30 degrees, is 1/2. So that'll be about right here. Okay, sine of pi over 4, or 45 degrees, that's about 0.70711, and it keeps on going, so that's about here. Okay. Sine of 60 degrees is 0.86603, so again, that's about here. Okay. Sine of pi over 2, or 90 degrees, is 1, and that's about there. Okay, and it keeps on going for all of those values of 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, and all the rest of them. Okay, so we plug all of those in, and we end up with a graph that looks like that. And then if we keep on going and plugging in, it looks kind of like It should be right there and there. But it should be 0 at 3 pi over 2. I kind of made it a little too steep. So it should be about right there. And then it goes in the other direction as well. So it goes like that, that, like that, and like that. Again, it's not the most flawless sine wave, but it looks kind of like that. Okay. So once you have your sine graph, let me even make this a little bit neater. And again, of course, because I'm drawing it by hand, it's going to be a little bit imperfect. But if you print it up, you'll see it kind of looks like that. Or if you go online and print up your graph, it kind of looks like that. Okay, so if you notice, kind of clean that up. If you just pay attention between pi and negative pi, if you get this portion of it and flip it over the y-axis and then again over the x-axis, notice you have your odd function. Or it's an odd graph. So sine of x is an odd function since it is symmetric about the origin. Okay, so what does that tell you? Well, that tells you that sine of negative theta, or negative x, is equal to negative sine of theta. Okay, so for example, what if we let theta equal pi over 2? And just to keep things symmetric here, I'll make this theta. Okay, so that means that sine of negative pi over 2 has to equal negative sine of pi over 2. Okay, what's sine of negative pi over 2? Well, negative pi over 2, sine of negative pi over 2 is negative 1. What's sine of pi over 2? Sine of pi over 2 is 1. So you have negative 1. Okay, so you know you have your odd graph or your odd function. Okay, so let's move this up and let's look at cosine. Okay, so cosine is pretty much the exact same thing. Where if you look at this really quickly, you have cosine of 0 is 1, cosine of pi over 6 is 0.86603, and it keeps on going. Cosine of 45 degrees is 0.70711, cosine of 60 degrees is 0.5, and cosine of 90 degrees, or pi over 2, is 0. Okay. And again, it goes the exact same way. So if we plug those values in, kind of looks like that. And then, of course, goes down like that, and up like that, and over to 2 pi. Okay. And again, it's the exact same thing on the other side. Kind of looks like that. Okay. Now again, if you notice, if you get your right side of cosine and you flip it over, it's symmetric about the y-axis. Okay, so what does that tell us? Well, that tells us that cosine of theta is an even function since it is symmetric across the y-axis. What does that mean? Well, that means that cosine of theta is equal to cosine of negative theta. Okay, so cosine of pi is -1. Cosine of negative pi is -1. Cosine of 3 pi over 2 is 0. Cosine of -3 pi over 2 is 0. Okay, so they're symmetric across the y-axis. All right. So if you are still writing, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our next graph. And that graph is tangent. Okay. So we know that tangent is equal to opposite over adjacent. But tangent is also equal to sine over cosine. Clean that up a little. Okay, why? Because sine divided by cosine is just sine is opposite over hypotenuse divided by cosine, which is adjacent over hypotenuse. Okay, so our rules for dividing fractions is that you write down the first one, so you have opposite over hypotenuse. Division changes to multiplication, and then you flip the second fraction. So that's hypotenuse over adjacent. The hypotenuse values cancel out, so that leaves you with opposite over adjacent. Okay, so tangent is equal to sine over cosine. Okay, what does that tell us? Well, it tells us that cosine cannot equal 0. Okay. So what values make cosine 0? Well, if you make theta means it can't equal positive or negative pi over 2, positive or negative 3 pi over 2, positive or negative 5 pi over 2, and so on and so on and so on. Okay, so that means for our pi over 2, that's a vertical asymptote. Same thing with our 3 pi over 2. That's a vertical asymptote. Same with negative pi over 2. Same with negative 3 pi over 2. Okay, so if you plug in all the values of sine and cosine, your graph will look like this. Because we know sine of pi is equal to 0. So at pi, your graph will be 0. So then it'll keep declining like that. And it has that same pattern for each and every interval between the vertical asymptotes. So we get that and we take it down that way. So this is the graph for your tangent of theta. Okay. Now cotangent of theta is pretty similar, but remember, cotangent of theta is just the reciprocal of tangent. Okay, so we know that, block this off. Cotangent of theta, if tangent is sine over cosine, then cotangent is just cosine over sine. Okay, what does this mean? Well, this means that sine cannot equal 0. Okay, so if sine of theta can't equal 0, then that means theta can't equal 0, positive or negative pi, positive or negative 2 pi, positive or negative 3 pi, and it keeps on going and going and going. Okay? Because you look back on the graph, sine of 0 is 0, sine of pi is 0, sine of 2 pi is 0, sine of 3 pi is 0, and so forth and so on and so on. Okay, so that means for our cotangent graph, 0 is a vertical asymptote. So I'll see how, I don't think you can see it very well, but we'll mark it anyway. Okay. We know positive and negative pi are vertical asymptotes. Same with negative pi. Okay. Positive or negative 2 pi, vertical asymptotes. Okay, so we have all of our asymptotes. And I'll just make that a little bit thicker so you can kind of see it. Okay. Now it looks almost identical to the tangent graph, but the only difference is it goes the other direction. Okay. So your graph looks like this. And we know that, remember, your numerator cosine is 0 at 3 pi, negative 3 pi over 2, positive 3 pi over 2. But our sine is 0 at the other values. So that's how we know that it crosses at negative pi over 2 and positive pi over 2. So it kind of looks like that on each interval. Okay, and again, drawing it by hand is going to look a little bit funny because I'm not measuring every little detail. But if you Google a picture of your tangent, cotangent, sine, and cosine graphs, you'll see the shape is pretty close. All right, so if you are still drawing this, feel free to press pause and finish up. We're going to do the last two, which is our cosecant and secant. Okay, so for our cosecant, you just have to remember that cosecant is just the reciprocal of sine. So cosecant is the reciprocal of sine. Okay, well, what does that tell us? Well, that tells us that cosecant of theta is equal to 1 over sine of theta. Okay, so that means we know that theta cannot, well, sine of theta cannot equal 0. Okay, so let's look at all the values where sine of theta is equal to 0. Okay, so if we draw a quick sine wave, so if we go like this and this and this and this, just a quick little dotted. Okay, so that's our makeshift sine wave. Okay, so all the points where sine is equal to 0, we know that for cosecant, that can't happen. So all the points where sine is 0 becomes our vertical asymptotes. Okay, same thing with 0. Same thing with positive pi. And same thing with positive 2 pi. Okay, so those are all the points where sine of theta is equal to 0. Okay, now remember, cosecant is just the reciprocal of sine. So in between these two asymptotes, we're just going to flip our graph. Same thing between these two. We're just going to flip our graph. Since all the reciprocal is flipping it, we're just going to flip our graph. Same thing here, we're just going to flip our graph. Okay, so if you look at all of the red, that's your graph of cosecant. Okay, so cosecant theta is in red. All right. So if you're still sketching, feel free to pause it. But we're going to go ahead and do secant of theta. And pretty similarly to cosecant, you just remember secant is the reciprocal of cosecant. So it's 1 over cosecant. Okay, well, what does that tell us? Well, that tells us that cosine, sorry about that, cannot equal 0. Okay. Well, let's look at a sketch of cosine. Okay. So cosine of 0 is 1. So it kind of looks like that, and then that, and then that, and then that. Okay. Same thing in the negative direction. It looks like that, then that, then that, then that. Okay, so it kind of looks like that. Again, it'll be prettier if you use a calculator or any other type of graphing machine, but by hand, looks like that. Okay, so that means any place cosine equals 0, we can't use it for secant. Okay, so that means 3 pi over 2, or negative 3 pi over 2, is a vertical asymptote. Negative pi over 2 is a vertical asymptote. Positive pi over 2 is a vertical asymptote. And positive 3 pi over 2 is a vertical asymptote. And it would keep going 5 pi over 2, 7 pi over 2, and so forth and so on. Okay? So since secant is the reciprocal of cosine, for this interval, it's going to go in the other direction. Okay? Between negative 3 pi over 2 and negative pi over 2, it goes in this direction. Between negative pi over 2 and pi over 2, it goes in this direction. Between pi over 2 and 3 pi over 2, it goes in this direction. And from 3 pi over 2 to 2 pi, it flips in this direction. Okay, so hopefully this kind of makes sense as to where the graphs of trig functions come from. Okay, again, hope it made sense to you, and I'll see you on the next video.